Okay, so the question that I'm going to do today is the 2017 higher level dynamic mechanisms question, C4 in the paper. So the first part is to do with cams. So it says cams are used for engines of quad bikes. Draw the displacement diagram and the profile of a radial plate cam which rotates in an anti-clockwise direction and imparts the following motion of an inline roller follower of diameter 18 millimeters. So what we need to do is start off by doing a displacement diagram, and here's the information regarding that. So it says the nearest approach of the roller center to the camshaft center is 40 millimeters. Okay, and the camshaft diameter is 20 millimeters. So it says use a distance of 12 millimeters for each of the 30 millimeter intervals on your displacement diagram. So first thing we need to do is from 0 to 120 is a rise of 36 millimeters with uniform acceleration and retardation. Okay, so that's what we're going to start with. So I'm going to start the question up on the top right hand corner of my sheet. I'm going to mark 60 millimeters. I'm going to draw in my completed height. So it says 12 millimeters between the distance of each interval. Okay. So a rise of 36 millimeters with uniform acceleration and retardation from 0 to 120. Okay, so we know from here to here is uniform acceleration and retardation. So the first thing I'm going to do is I'm going to have to find the center line. So there's the center line of that, and that's a rise of 36. Okay, so what we need to do then is put our vertex at each end. So you have one vertex down there, and then you have your other vertex up there, and there's your center line in the middle. So what we need to do then is we have to divide up our height of our box, because half of it is going to be acceleration and the other half is retardation. So half of that then is going to be 18 millimeters. So we know now that's the common point that both of them share. What we're going to do now is divide this up here, and we're going to split it up 24. So we're going to have 6, 12, 18. Okay, so we have 4 sections there. We have 4.5, 9, 13.5, and the top one. So if you join them up to your vertex, again it's like drawing an upside down an inverted parabola. So you have 1 point there, 1 point there, and 1 point there. Okay, so then you can join them up then with a smooth curve. Okay, so we're going to repeat that now up here. So again, I'm going to divide this into 4 equal sections. I'm going to draw these then down. Then I'm going going to divide up the side. So 4.5, 9, 13.5. Draw them up to your vertex. Probably the hardest part of dynamic mechanisms is the uniform acceleration and retardation. The key thing is that you have your vertex at each end. You have the height because half is going to be acceleration, the other half is retardation, and then after that, then what you need to do is you divide up the common line in the middle into equal parts, divide up the base into equal parts, draw them up in your acceleration part, and then for the retardation part you do the exact same thing. So it says then from the motion is rising 24 millimeters with uniform velocity from 120 to 180. So we're at 120, so we're going up to 180, and it's a height of 24, so we had 36 plus 24 is 60, which I marked up already. So uniform velocity is a straight line. Okay, so that's easy. The last part then is the motion is to fall 60 millimeters with simple harmonic motion. Okay, and that's from 180 to 360. So from here to here now, we're going to fall with simple harmonic motion. So the first thing we need to do is figure out how many divisions have we, or intervals have we. So we have 1, 2, 3, 4, 5, 6. Now that makes it handy because we have to draw a semicircle when we're using simple harmonic motion. So the first thing I'm going to do is just bisect this here, find my center, and draw my semicircle. Okay. After that, then you're going to divide up your semicircle with your 30 and your 60 degree on your set square. Okay, so because we're falling, we're going to start up here. So this is going to be 1, 2, 3, 4, 5, and back down to 6 below at the bottom. Okay, because we're falling. So again, then this is going to be our number 1, 2, 3, 4, 5, and 6. Okay, so what we need to do now is bring each point horizontally across to meet up with its corresponding line. Then put a dot then where each point meets, and then what you need to do then is draw a freehand curve. Okay, so that's your displacement diagram for the start of the question. Okay, right, so what it says then is, if you read the next part, it's a roller follower and it has a diameter of 18. So because it's a diameter of 18, it has a radius of 9. Okay, so just make a note of that. Radius 9. And then it says the nearest approach of the roller center to the camshaft center is 40 millimeters. So from center to center is 40, and the camshaft diameter is 20. So again, radius 10 millimeters is the camshaft. and then that's the roller follower. So now what we need to do is we need to draw our cam. So we know that the first point, 0, if I draw that out, that's going to be the center of my roller follower when it's at 0 degrees. We know that the radius is 9, so I'm going to set my compass to 9. Okay, so that's the first roller follower. Now, from that to the center of the camshaft follower is 40 millimeters. I'm going to measure down 40, and that's the center now of the camshaft follower, and that's radius 10. Again, now I like to use 2 compasses for this one, set to the roller follower, then the other one then I can use freely. Set that to 10, and then that's your camshaft center. Okay. So what we're going to do now is just going to mark that one there is going to be 0 degrees up top. Okay. So from there then it says that it's going to be rolling anti-clockwise. So if it's going to be rolling anti-clockwise, which is this way, you have to number the opposite way, because if the cam rotates this way, the numbers then are going to be on the opposite side. So if the cam is rotating this way, what you need to do then is you need to number clockwise down this way. So what we're going to do is we're just going to draw out our different radiuses. So that's going to be the minimum radius. The minimum part of the cam. And then to bring across our points then to create our cam. So what I'm going to do is split up from the center my camshaft, draw out my lines, okay. So for the first interval it's 30 degrees. So you have to bring them all over to this center line. So what I'm going to do is I'm going to bring over my points now from my 30 degrees, 60 degrees, 90 degrees, and then 120 degrees. I'm going to start with the first motion, which is uniform acceleration and retardation. So you're going to rotate these first, and these now, remember, are the center of each of your roller followers on your cam. Then using my other compass then, what I'm going to do is draw in my cam at each point. These small radiuses too can be very difficult to draw in. Okay, so that's for 30 degrees, 60 degrees, 90 degrees, and 120 degrees. So next part that I need to do now is the uniform velocity. So we have 120, so I need to get 150, bring that across, and then we have 180 then up the very top, which I have brought across already. So I'm going to rotate them around. And then the top one then. There's my compass, that's set to 9. Okay, so the last part then I have to do then is figure out then where we get our simple harmonic motion from. So at the points where it hits each one, you bring that across to your vertical line just above where your inline roller follower is. And then we're going to rotate each one then onto the corresponding line. And the last one then finishes right back down at 0 again. Okay, so there are the centers. Again, with your compass then, just make sure now each of your points is drawn correctly. So that's 150 degrees, 180 degrees, then we're on 210 degrees, 240 degrees, 270, 300, 330, and then back to 360. So 300 degrees, bring it over, rotate it, so there it is there. Always make sure that you have the correct line on the correct interval. Okay. So with your roller follower then, what you need to do is your shape of your cam should be in the shape that it's tangential to each of these circles at the different intervals on your cam. So you have to draw a smooth curve that joins up each, and it has to be tangential to each of your circle. So my advice is to go around it first, over it heavy, to outline your cam. Okay, so that's your displacement diagram, and then your cam for an inline roller follower. Okay, so now we're going to move on to part B of the 2017 Higher Level Dynamic Mechanisms question. So it says the graphics on the right show an enlarged view of the gripper mechanism on a robotic arm. The details of part of the upper jaw of a similar gripper are shown in the line diagram format in figure C4b below. Jaw AB is pin jointed at B to link BC. AB always remains horizontal, so that's important. This is always going to remain horizontal. It's pin jointed here, so it joins AB and BC together at point B. Draw the horizontal axis C to C2, the link BC and the horizontal jaw AB as shown. So we're going to start with that part first. So from C to C1 is 120, and then further 6 millimeters then over to C2. I'm going to draw that in. Then what I'm going to do then is a mark point C, C1, C2. Draw the line then at 30 degrees, and then it's up to a height of 50 millimeters. And then that's point B, and then we measure back then 6 millimeters in point B. So this is the start off of the question. So if we look at part B then, part B says the entire mechanism ABC moves to the right as indicated by the arrow X. So the arrow X is moving to the right until C reaches C1. At the same time, the link BC rotates clockwise about point C through 60 degrees to a vertical position. Plot the locus of A for the combined movement. Okay, so at the moment you have BC and it's at an angle of 30 degrees. It's going to move to an angle of it's going to move through an angle of 60 degrees into a vertical position, and in doing that then what's going to happen is it's going to move from C to C1. So in moving through 60 degrees it's also going to move a distance from C to C1, which is 120. So what we're going to do is we're going to divide the line from C to C1 into 6 equal parts. So each part then is going to be 20, 40, 60, 80, 100, 120. Okay. So we're going to label these then. 1, 2, 3, 4, 5, and then 6. Okay. So as that arm moves then to our new point, what we need to do is we need to plot the locus of point A. Okay, so the length of A to B is still going to remain the same. The length from B to C is still going to remain the same. And AB is still going to remain horizontal each time. Okay, so the first movement is going to be through an angle of 10 degrees. So our angle is going to be 40 degrees. So you put down your protractor and mark off 40 and draw out a line. Now, be very handy to have if you have 2 compasses, to have them set, one to the length from B to C, and then the other one then from the length from A to B. Just makes this an awful lot quicker. So that's that one set, and then from A to B, that's that one set. Okay, so I'm going to draw out my line, and then at that point mark off B1. Then I'm going to draw the horizontal line, and then at that point I'm going to mark A1. Okay, so there's point A1, and there's B1. So again, it's going to move a further 10 degrees, so this time it's going to be 50, and it's going to go over to point 2. Draw out your link arm, mark off the distance, there's B2, draw a horizontal line, with your compass, mark off A2. Okay, so what we're going to do now is just going to repeat that then for the rest of our points. So because we have to plot the locus, then we need to join up points from A to A6, okay, with a freehand curve. Okay, so that's part 2 of part B of dynamic mechanisms. The last part then says the entire mechanism ABC then moves further to the right with point C now moving from C1 to C2. So now it's going to move from here to here. At the same time, the link BC rotates 60 degrees anti-clockwise about point C. On the drawing, plot the locus of point A for the second combined movement. Okay, so what's going to happen now is it's at a position where it's vertical and it's going to start rotating back anti-clockwise through an angle of 60 degrees until it reaches its starting angle, which was at 30 degrees. Okay, so again, what we're going to do is we're going to divide this up into tens this time because it's only 60 millimeters, and they're going to be our different points. So we're going to have 1, 2, 3, 4, 5, 6. Okay. So that was the starting angle. So what's going to happen now is at point 1, the angle is going to be 80 degrees. Okay, so mark 80, draw up your line. Mark B1. And then draw out a horizontal line. So on this line now is going to be our point. That's going to be point A1. So our next angle now is going to be 70 degrees from point 2. So at point 2, mark 70 degrees. Draw out a light line, and then again have your compass set to both your measurements. Here's B2. And remember, A to B is always going to be horizontal. Draw that out. And on that line then mark B2. Sorry, A2. Same thing again. So you're going to repeat this for the 6 different movements. So mark your points. Draw your lines at each point. So then draw a freehand curve then that represents that motion. Okay. And that there then is part B of the 2017 higher level dynamic mechanisms question completed.